Hey everyone, welcome back to the Cloud series. So far, we've talked about containers, Kubernetes, and how modern apps run in the cloud. But what if you have huge amounts of data, and you want to analyze it fast, build AI models, or run big data pipelines? That's where Databricks comes in. If you've ever heard terms like Apache Spark, big data, data lakes, or AI pipelines, there's a good chance you've also heard about Databricks. But what exactly is Databricks? How does it work? And why is it such a big deal in cloud and data engineering? Let's break it down in simple terms. What is Databricks? Databricks is a unified data analytics platform built for big data, machine learning, and analytics all in one place. It's built on top of Apache Spark, a powerful open source engine for processing massive datasets very quickly. But Databricks makes Spark easier to use, scalable in the cloud, and adds a ton of features for collaboration, automation, and AI. Think of it like this. Apache Spark is the engine. Databricks is the full car with steering, brakes, dashboard, and even GPS ready to drive your data from raw to ready. Real-life analogy. Imagine you're building a huge Lego city. You have teams working on roads, buildings, cars, and people, and each team needs access to shared materials, blueprints, and instructions. Databricks is like the central workshop where everyone collaborates. It provides all the tools you need: data, compute power, notebooks. Everyone works in sync: data scientists, engineers, analysts. And it helps automate the building process, with jobs and pipelines. In short, it's where big data projects go from idea to model to production. Key features. Let's break down the core features that make Databricks powerful. Unified workspace. You get collaborative notebooks that combine code, visualization, and notes, great for both Python and SQL users. Managed Apache Spark. No need to install or manage Spark clusters. Databricks handles that for you, scalable, secure, and in the cloud. Delta Lake. An advanced data storage layer that adds reliability, ACID transactions, and version control to your data lake. MLflow integration. Built-in tools for training, tracking, and deploying machine learning models, all from one place. Job scheduling. Automate your data pipelines and run scheduled ETL, training, or analytics workflows easily. It's a one-stop shop for modern data and AI development. Databricks architecture. Let's look at how Databricks is structured behind the scenes. Workspace, the main interface where users collaborate. Clusters, Spark-based compute engines that run your jobs. Jobs, workflows and pipelines that can be scheduled or triggered. Notebooks, interactive coding environments. DBFS, Databricks file system, a place to store your files and datasets. Databricks can be deployed on AWS, Azure, Google Cloud. And it integrates with popular data tools like Kafka, Snowflake, Power BI, and more. Why use Databricks? Databricks is designed for teams working with huge datasets, machine learning, and real-time analytics. Here's why companies love it. It's cloud-native and highly scalable. Speeds up big data processing with Spark. Makes AI development and deployment easier. Encourages collaboration across teams, devs, data scientists, analysts. Helps manage your entire data journey, from raw data to ML models. Whether you're building a recommender system, real-time dashboards, or training models, Databricks can handle it. Who uses Databricks? Databricks is used by major enterprises around the world, including Shell, Energy Analytics; Comcast, real-time streaming data; Regeneron, AI-driven drug discovery; HSBC, financial risk modeling. From healthcare to finance to retail, if you need to handle data at scale, Databricks is probably part of the stack. Databricks versus traditional ETL. Before we compare, what is ETL? ETL stands for extract, transform, load. It's a process used to move and prepare data. Extract, pull data from various sources, databases, logs, APIs, etc. Transform, clean, format, or join the data so it makes sense. Load, push the transformed data into a data warehouse or analytics system. Traditional ETL tools are often batch-based, slow, and hard to scale, especially when dealing with big data or real-time analytics. Let's compare Databricks to traditional tools. Speed. Traditional ETL usually processes data in batches. This means data is updated hourly, nightly, or even weekly. Databricks, built on Apache Spark, a powerful distributed computing engine. It processes data in parallel across many nodes, making it incredibly fast even with massive datasets. Think of it like comparing a slow-moving conveyor belt to a high-speed data highway. Collaboration. Traditional tools, developers often work separately. Sharing scripts and data workflows usually involves sending files, emails, or using version control manually. Databricks offers real-time collaboration with shared notebooks. Multiple people can work on the same code and see changes live. It's like Google Docs, but for data engineers and scientists. Machine learning. Traditional tools, typically, you'd have to export data to a separate ML tool, like scikit-learn or TensorFlow, train your model there, and then bring it back, a messy and time-consuming workflow. Databricks comes with MLflow, a built-in machine learning lifecycle tool. You can build, track, and deploy ML models right within the platform. No jumping between tools, it's all in one place. Data freshness. Traditional tools, mostly built for batch jobs. You might only get updates once an hour or once a day. Databricks supports real-time and streaming data pipelines, so your dashboards and models can use the most current data. Perfect for live dashboards, fraud detection, or monitoring sensors in real time. So that's Databricks, a powerful, all-in-one platform for working with big data. From cleaning and transforming data to building machine learning models, it brings everything together in one place. If you're in data science, analytics, or engineering, this is definitely a tool worth exploring. In the next episode, we're diving into data centers, what they are, how they work, and why cloud providers rely on them. If this video helped, give it a like, drop your questions in the comments, and subscribe for more cloud-powered learning. Thanks for watching, see you in the next one.